Welcome to Ethereum Cat Herders meeting. We are joined by a team to maybe provide a demo under the section called Ecosystem Project Demo. Let me welcome Ben from Team Gelato. Welcome, Ben.
Hey everyone, how's it going? Thank you so much for having me. Yeah, I'll be giving a quick presentation followed by a demo.
Awesome. The floor is all yours, Ben. Please go ahead with the presentation and the demo. If we get some time, we will perhaps take some question answer at the end of this presentation.
Perfect, thank you. So today we're going to be covering signless transactions powered by our relay service called Gelato Relay. First of all, a quick introduction to Gelato. For those of you who are not familiar, Gelato is Web3's decentralized backend, empowering builders to augment their smart contracts to create reliable, user-friendly, and scalable Web3 apps without sacrificing decentralization and censorship resistance. So traditionally, when developers sort of first start out, it seems like all we really need is a front end, and then we need some smart contracts on chain. And that's sort of all we need. That is our decentralized backend. But as applications scale, a lot of them find they need sort of extended functionality or additional infrastructure in order to power the variety of use cases. And this is sort of where Gelato comes in. We offer 3 services. First one being an automation service, which allows developers to execute smart contracts automatically when certain criteria is met. So this could be, like rent payments, which happen every month, or it could be liquidating users when their health factor goes below a certain threshold. We also offer a relay service, which simply allows you to execute transactions or to put transactions on chain in a gasless manner. And we abstract away some of the complexity there. So block reorgs or failed transactions, also pricing the transactions correctly, etc. And the final thing is Web3 functions, which is sort of similar to Automate, but a bit more powerful, since you can also access off-chain data and execute smart contract functions based on that off-chain data. Yeah, and finally, the other piece you might have in your sort of back-end stack puzzle is some data storage solution, like, for example, IPFS. It's actually worth noting that our Web3 functions, they're written in TypeScript, and that TypeScript, the source code, is deployed on IPFS. So it's decentralized and it's immutable. So yeah, the agenda for this sort of quick presentation is to briefly cover Gelato Relay, then discuss some account abstraction, then discuss a safe session module, which allows the signless trading, and then just giving a very quick demo at the end. So Gelato Relay enables gasless transactions on all major EVM compatible networks. First of all, sort of more broadly, what is a relayer? By definition, to relay means to receive some information and then subsequently pass it on. Sort of in the context of Web3, this means we have an EOA executing a transaction on someone else's behalf. So the EOA is receiving the transaction and then it is passing it on or putting it on chain. More specifically, what is Gelato Relay? Gelato Relay is simply a decentralized network of these relays, also known as executors, and it can be considered a sort of marketplace bringing together 2 parties. The first being developers wanting to relay users' transactions, and the second party being infrastructure operators, which execute these transactions in exchange for a small fee. Now, relaying has some interesting implications. The first being that the relayer incurs the gas fee and not the user, since it is the relayer who is putting the transaction on chain. And this is actually a really nice thing because it gives the user having their transaction relayed unlimited freedom in how they want to handle the payments. So transactions can, for example, now be self-paying using any sort of tokenized asset, for example, USDC, other ERC20 tokens like ERC721 as well, like NFTs we could support. All the transaction can be sponsored. So a project can set up a balance on our service called OneBalance, and it can decide to, for example, sponsor users NFT mints to offer sort of this like frictionless onboarding. The main point sort of being that the user is no longer restricted to paying in native tokens and also no longer restricted to paying at the time of execution. So we have these sort of deferred payments, which gives us a lot of freedom and opens up some really cool use cases. Here's a quick flow diagram of a sort of gasless NFT mint using a safe. So this is a bit of account abstraction, which I'll sort of elaborate on later. Let's imagine we have some EOA. So this is sort of the owner of the safe. In the case that we're using ECDSA, for example. This wallet has no Ethereum, so it can't actually transact. But what it can do is it can build, for example, a mint transaction, and it can sign this transaction using its private key. This transaction can then be sent to Gelato, to our executor service, our relay service, using our relay SDK. It makes it super easy. And then one of our executors, we have this sort of decentralized network of executors, will pick up this transaction and then subsequently put it on chain. So here we move from the off-chain world to the on-chain world. This will call the safe contract, and this can do sort of arbitrary signature verification, whatever logic it wants to perform. And then it can forward this mint transaction to, for example, an NFT contract, which then mints the NFT to the safe. So this is a really nice sort of flow, but you may have noticed that for sort of each transaction we want to execute, we have to sign the transaction. And this is sort of a pop-up on MetaMask if we're using MetaMask or whatever wallet we're using. So ideally, rather than signing each individual transaction, we'd like to instead sign sort of one intent, which creates a temporary session that has an expiry. And this session is associated with a certain public key, and that public key is derived from a private key that we generate on the front end of our application. And this temporary wallet then signs all subsequent transactions. And it can also support multiple concurrent sessions on, for example, multiple devices. So if we have, like an exchange, we can sign intent to say we want to trade for 1 hour now, and all of the subsequent transactions will be signless. So we don't need to have all these MetaMask pop-ups for every individual trade we make. Same goes for like sort of gaming applications, where each interaction doesn't have to be a MetaMask pop-up. It sort of removes some of the immersion that the user would otherwise have. What we can also do with the signless module is we can define very strict whitelists. So we can say that we only want certain methods to be executed through our safe. This is sort of a security thing. And we can have sort of whatever criteria we want here. Finally, we want to be able to execute transactions as long as the session is valid and as long as it satisfies this criteria. So for example, the whitelist, but it could be other things as well. Why are we using safes in the first place, or account abstraction? The nice thing is that we essentially have these on-chain wallets, which are fully programmable. And because they're fully programmable, they can have arbitrary verification logic. So we can have ECDSA signers, so traditional EOAs like MetaMask, but we can also support native social login. We can also support session keys, sort of what we're covering today, but we could even have like biometric login, sort of fingerprints or Face ID, whatever we want really. We also have native atomic multi-operations, so we can approve spending of a token and then have it spent by a contract or within one transaction. It doesn't have to be 2 separate transactions. We also have semi-abstracted nonces, so we have these concurrent execution channels where we can, execute one transaction sort of parallel. And we also have gasless transactions, which allow us to either sponsor transactions or pay using ERC20 tokens. And the super nice thing is that this is out of the box compatible with all existing smart contracts because we're using message sender. This is sort of in contrast to trying to relay transactions using an EOA where we have to use a standard like ERC2771. So how this works is we introduce a safe module. We just call it like a session safe module. It's essentially just a singleton safe module, which manages all sessions for all safes that are using it. So all we have to do is deploy the singleton. This is done by us, so the user doesn't have to do this. And then all the user has to do is enable the module on their safe. And the way the interface for the safe module looks, we have essentially all the features I sort of outlined here. We can create sessions using a session key. We can specify duration and also the public key of this sort of temporary wallet we've generated in our client. We can also whitelist transactions. So we can have this like very specific criteria, what we want to allow to execute. We can say we only want certain tokens to be able to be transferred from our safe, etc. And we can obviously also remove this whitelist if we no longer want the transaction to be executable. And finally, we can execute transactions given a session ID, which we've created up here, and given the transaction itself. So just to visualize the flow a bit, we have a safe. Well, step 1 is to, on the safe, enable this Gelato safe module. So on our safe, we enable this safe module here. The second step is that the safe whitelists our target, contract, or transaction in the Gelato safe. So we go to our safe, this is step 2, and we whitelist this. On the safe module, we whitelist certain transactions that we want executable. On an NFT contract, this would, for example, be a mint transaction. In step 3, we actually create our session. So again, we go through our safe, and that calls into our Gelato safe module, which then creates the session. And finally, step 4, when we actually want to execute a transaction, we can use this temporary session key, and we can relay a sponsored call using Gelato Relay directly to our Gelato safe module. And this is whitelisted by the safe, so it can execute on behalf of the safe and then call the target contract to, for example, mint an NFT. And yeah, now for a quick demonstration. In this case, we're not minting an NFT, but rather we're just incrementing a counter, just a super simple sort of showcase. And yeah, we created like a small UI for it. So we can connect our MetaMask. First, I'll demonstrate a non-signless transaction, so just a regular transaction. This is still being relayed, so it is gasless. So when I press trade, this will increment the counter. But first, it will ask for a pop-up on our MetaMask, and this will ask for a signature. So this is sort of what I was talking about earlier, where we have a signature pop-up every time we want to do this. We sign the signature. Again, it's being relayed, so the gas is sponsored on our behalf. And if we refresh the counter, we should see it's incremented. Yeah. And if we do this again, I won't actually execute it again, but if we do it again, there'll just be another pop-up. And if you imagine this is an NFT game, that sort of takes you out of the immersion because the MetaMask is popping up the whole time. So what we can do is we can enable the signless module. And this will ask sort of one signature, but the signature is only required once. And then we can, for example, press this trade button for the next hour and it won't keep asking for pop-ups. I think Gurley may be a little slow at the moment. I think it was just an issue with the actual RPC. I think it was taking a second. Anyway, now Sinus is enabled. We can press trade. And this time around, there's no MetaMask pop-up. So it's all just happening in the background. The message has been signed with the sort of wallet that we've created and it's stored in our browser temporarily. Yep, so the count is incremented. I can hit it again, no pop-up. And this will be the case for the next, sort of n minutes. I think it's 60 in this case, so 1 hour, but it's sort of completely configurable. And you could have completely different criteria. It doesn't have to be based on time. It could be based on something completely different. Yep, and the count is now 6. Yeah, just to wrap up, quick recap of the other services. So this was Gelato Relay. The other service we offer is the Automate service, which allows you to do on-chain automation, essentially performing any arbitrary computation without requiring user interaction. So like I said, liquidations, paying rent, limit orders, etc. And then we have Web3 functions, which is like sort of Automate on steroids. It's written in TypeScript, stored on IPFS, and then run by Gelato. And these allow us to bridge the gap between multiple chains. So by default, you have these RPC providers, which you can just natively use within this Web3 function. And it also bridges the gap between the on and off-chain worlds. So we can use this to push, for example, price oracle data on-chain. And that's what we do for Pyth, for example. And all these services can be self-paying or sponsored using this universal paymaster we have, which is called OneBalance. And that works across all services and also all networks. Yeah, thank you very much for listening. That's all for now. If you want to check us out, the website is gelato.network. We also have a Discord, a great developer community if you want to check that out. This is the invite link. Our Twitter handle is Gelato Network, and my Twitter handle is Ben Price with a V at the end. Thank you very much.
Thank you so much, Ben, for this great presentation. It was really interesting to learn something new going on in the ecosystem. I see we have questions in chat. Paresh, if you would like to maybe read the question for the guest.
Yeah, sure. I just wanted to understand if you could also do like a manual revoke on a safe, or is it always time bound?
Yeah, so just the first question, that's absolutely something you could implement in the module itself. Of course, in the safe, you could always unwhitelist this module. So you're sort of trusting this module, but if you want, you can always remove the whitelist, or you can implement some custom logic for extra verification. So it doesn't have to be time-based. You could have a manual thing to allow you to revoke sessions, for example, like you mentioned, yeah. All possible.
Cool.
And that's, it's sort of just, yep, sorry, go ahead.
No, please go ahead. Sorry to interrupt you.
I was just going to say it's possible because you can essentially implement anything you want. That's sort of the super nice thing about account abstraction, that we have everything is like fully programmable.
Yeah, that's awesome. And the second question was, is a safe created per smart contract a user wants to interact with, or is there a single safe for like interacting with multiple functions?
Yep. So it would be a single safe, and then you can interact. It sort of replaces your EOA in a way. You still have this sort of owning EOA in the case of safes. Obviously, with like ERC 4337, where we have like native account abstraction, you no longer need the EOA. But the idea is that you have like one smart contract wallet, and that allows you to interact with all existing smart contracts sort of out of the box. But you get these like nice properties, which is that you can sort of have these custom like signature validation schemes, and you can basically program anything you want. So you can have like rent payments every month, etc. Also worth noting on the UI, if you don't already have a safe, it will automatically create a safe for you. And that's part of this like account abstraction SDK that we offer.
Brilliant. Thank you so much.
Thank you.
I see there is another question in the chat. Joshua, if you would like to read it for the guest.
Sure, I was just elaborating on what you had just said, but my understanding was that the safe can be replaced with any smart contract wallet in this setup. Is that correct?
Yep, exactly. And there's so many out there, so you can really just sort of pick and choose, even create your own if you want. The idea with Safe is obviously that you can use Safe as sort of this like smart contract account kernel, and then you can extend it with these modules. But obviously you can just create your own as well. Yeah.
Okay. I did have another question. So I think gas deference and signless transactions with account abstraction are absolutely huge for Ethereum and for any EVM compatible blockchain. I'm curious how Gelato thinks about the security model for like its end users and how they approach security in this new paradigm, and also how Gelato thinks about security internally and like its own code and audits and things like that.
Yep, great question. So all our code is obviously audited, not just the smart contracts, but also this sort of backend that we have. And the idea of Gelato is it's not just this sort of single point of failure relay system, but rather sort of Gelato's bread and butter is this like decentralized network of executors, which powers all of these services. And we're sort of we have multiple executors already in our network, but we're moving towards making that like fully permissionless so that anyone can sort of contribute. So it essentially emulates like a blockchain.
Amazing. Thank you.
Thank you.
I have another question with respect to EIP. You mentioned about account abstraction, but we also noticed that there are some certain features which also allows to not pay in native token. So which is the EIP being used here? Is it EIP 4337, 3074, or anything else?
So this is not 4357. It's not native account abstraction sort of. Instead, in this case, we're using one balance, which is a sort of paymaster. In this case, it's an off-chain paymaster, and we're actually working currently on getting that integrated with 4337. But obviously, you could use 4337 and have this sort of on-chain paymaster, which can accept ERC20 tokens, also sponsor transactions. So it's sort of like it's a different way of doing the same thing in a way. But yeah, it's not 4337. Yeah.
Right. I'm aware that 3074 perhaps provide this facility to pay it in any other token rather than the native token. So you may take a look at that proposal, or in any case, if you guys are trying to come up with a new EIP, we would always welcome something new in the Ethereum ecosystem. Next point I wanted to mention here was about the use cases. So you talked about gasless NFT mint, like that is a really good use case here. Like there are so many people involved in NFT. Have you recently seen any other use case those are being used on Gelato network by any other users or implementers of it?
Yeah, we see really cool use cases. I don't have like a list or anything prepared, but we had some really cool ones. NFT minting, NFTs are pretty huge. Gaming is also sort of starting to take off, so that's really big. And there's also a lot of throughput there. And obviously both of these, you really want a really nice onboarding experience because we're trying to onboard like Web 2. So having gasless transactions is sort of essential there. Also lots of exchanges, we're sort of focusing on DEXs a lot. Also very high volume, obviously, and it would be nice not to have to pay gas there as well. So the sky's sort of the limit, though. I mean, most protocols I think could benefit from, or most dApps could benefit from gasless transactions.
Absolutely. And onboarding Web2 community is one of the biggest use cases, I can say that. So definitely kudos for that. During the demonstration, you mentioned about using the Garley network. I was just wondering, have you guys considered switching to Sepolia network? I know Halsky is not ready yet, but these are going to be the public testnet, which would be available or maintained by Ethereum developers for a long time.
I think so, yeah, absolutely. The testing is super important to us. Yeah, I also think Gurley is sort of a bit outdated at this point, so I think we're definitely considering switching. Yeah, it should be a really nice sort of testing setup where you can test everything sort of on testnet and then deploy in mainnet and should have exactly the same behavior. So yeah, we're considering other test networks as well. It's worth noting that we don't just support Gurley, but also like Mumbai if you want to test on sort of the Polygon testnet and sort of all the other testnets for these big chains. Yeah.
That is awesome. So Godly is going to be replaced by Halsky. We are expecting its launch somewhere this month, like by the end of September. Once that is like ready, we can perhaps recommend you to switching on to Halsky. But in the meantime, Sepolia is another test network which is publicly available for testing dApps.
Mm-hmm. Super cool. Yeah, thank you.
Very well. Thank you so much, Ben, for this presentation here. It was really interesting to learn about another project in the ecosystem that may be useful for many normal user, many Web2 user, and people who are looking into creating projects, making smart contracts with the help of Gelato network. We wish you all the best. Thank you so much for taking out time to be here today.
Thank you so much for having me, and yeah, thank you for all the questions.